All right, number 13, find the altitude of an equilateral triangle with a sine length of 32. This is just like 11 and 12. So we got 32 here, a 32 here, draw my altitude, and half of 32 is just 16. So I'm just going to go ahead and put 16 and 16 there, because don't forget it all has to equal 32. They both have to add up to 32. Okay, so same old, same old. This is a right triangle. If you take half of an equilateral triangle, it's going to be a right triangle. And we're going to use the Pythagorean theorem like this. Again, this is A, this is B, this is C. And we're just going to plug in what we know. 32 squared minus 16 squared. And then we're going to get that A equals 27.7. So the altitude of this triangle is 27.7. All right, number 14. So this time the altitude is already drawn for us. It says to find x if the measure of angle AD, wrong way, ADC, so this is the angle ADC, equals 3x plus 15. Now again, this is an altitude problem, so that means that we have to choose from the altitude list of equations. Don't forget, altitudes are perpendicular to the base of the triangle. So that's a 90-degree angle. So we're going to use this form for this particular problem. So that's going to be 3x plus 15, that's the angle, equals 90. And then when you solve for x, you should get, not 75, 25. Okay. And it just told us to find x, so we are done. You can plug it in to check your answer, of course. Number 15, AD is the altitude. So again, since it's the altitude, I know it makes a right angle. And then it tells us that ADC, so A to D, go over to C, is 6x minus 12. So that's an angle. So again, we're going to use the angle equals 90 form. And so 6x minus 12 is the angle, and then it equals 90 degrees. And then when you solve for x, you get 17. All right, and it just said to find x, so we are done. So yeah, just find x. All right, number 16. BD is an angle bisector, so that means these two angles are congruent. Let's see. The measure of angle DBC is 10y plus 3, and DBA is 8y plus 10. And then it wants us to find the measure of angle DBC. All right, so again, those two angles are congruent, so this is a part equals part problem. And don't forget, this is an angle bisector problem, so you know it's going to be part equals part by that list that I gave you. Okay, so now we have 2y. Sorry, I was about to solve it by hand. Anyway, so if you use and solve, you should get that y equals 3.5. Then you need to plug it back in. So the measure of angle DBC is going to be 10 times 3.5 plus 3, which is 38. And then we're going to check our work by checking DBA. And that's going to be 8 times 3.5 plus 10. And that's also 38. So since they're both 38, they were supposed to be equal, remember? So we're good. And the measure of DBC is 38 degrees. Make sure to put degrees here, since we're talking about angles. All right, number 17. Again, we have an angle bisector, so these angles are congruent. These segments are also congruent. And we need to find x. So since this is an angle bisector problem, if you look at that list I gave you in your notes, you know this is going to be part equals part. So that's 2x plus 30 equals 3x minus 4. Okay. So if I solve for x, I get 34. And that's the only thing I needed to do. So we're done. And of course, to check your work, you want to plug that back in to make sure they are actually equal. Number 18. So again, we are dealing with an angle bisector problem. So that means that this is a part equals part problem. So we have our EG and our FG. So they are equal to each other. Part equals part, guys. 5x plus minus 10 equals 3x plus 12. And when you solve for x, you get 11. All right. We're not done yet because it says to find EG and GF. So EG equals 5 times 11 minus 10, which is going to be 45. FG equals 3 times 11 plus 12, which also equals 45. They're both equal to each other, so we're good. And it asked us to find both. So we're done. All right, number 19. Point A is the in-center. So since this is in-center, this is talking about angle bisector. So this is another angle bisector problem, which means it's going to be part equals part. All right, so AB is here, AD is here. Yep, definitely part equals part because those two parts are congruent to each other. So set it up and solve it. Okay, so we get x equals 20. Are we done yet? Nope, it says to find AC. So we're going to plug it into AB. And that equals 225. And then we're going to plug it into AD. And that's also 225. And AC is right here, and it's also going to be congruent. So that's still going to be 225. And we're done with that. Number 20. BD bisects ABC. So that means those two angles are congruent. The measure of angle ABD is 5x minus 3. And the measure of CBD is 8x minus 9. Since we're talking about angles being bisected, this is going to be an angle bisector problem, so it's definitely part equals part. And so just make them equal to each other. So 5x minus 3 equals 8x minus 9. And then when you solve for x, you should get 2. All right, so now that we have that, the next thing that we need to do is to plug it in. So we have the measure of angle ABD equals 5 times 2 minus 3, which is 7. The measure of angle CBD, which is 8 times 2 minus 9, which also equals 7. And it wants us to find ABC. So ABC is the whole thing, ABC. So what we're going to need to do is take both of those and add them together. So the measure of angle ABC is 7 plus 7, which is just 14. So this is 14 degrees. Since it's an angle problem, it's degrees. All right, next problem. Tell whether the following measurements can be lengths of a triangle. So I told y'all before, add up the two smaller numbers and see, is it greater than the third number? And if it is not, then the answer is no. 5 plus 7 is 12. Is 12 greater than 10? It is, so that's a yes. And that's how you do those two. Number 23, we're going to list the angles from least to greatest. Least to greatest, so look at the side lengths, look for the least one, and then the angle across from it will be the smallest angle. And then keep going in order. And then the greatest one is 15, so that means the biggest angle is A. Okay. And number 24, find the measurement of each angle and list the sides from least to greatest. So again, this is an angles problem. Part plus part plus part equals 180. And we're going to add all those parts together. And we're going to solve for x, and we're going to get 28. Then we're going to plug that back into each one. So the measure of angle A equals 2 times 28 plus 10, which is 66 degrees. The measure of angle B is 2 times 28 minus 6. I put an extra parenthesis there for no reason, which equals 50 degrees. This problem should look really familiar. The measure of angle C equals 2 times 28 plus 8, which is 64 degrees. Okay, and now it says to list the sides from least to greatest. So look at the angles. The smallest angle is 50 degrees, and the side that's across from it is AC. So AC is the smallest side. Next we have 64 if we're going in order from least to greatest. So the side across from that is AB. And then the greatest angle is 66, so the side across from that, BC, is the longest side of the greatest side. Sorry.